Hello, this lesson is over simple probability again. However, this time we are using, we're going to be focusing more on number cubes, dice, in a layman term or simple common language. So let's think. The probability of selecting red is what from this? Let's count how many cubes there are. Where are my calligraphy pen? I see one. Whoops. Let me do that again. Calligraphy pen. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a total of 12 choices to choose from. And outcome 1, 2, there are 3 red. So it's 3, 12. Can you rename that as another fraction? Because I want to figure out what percent that is. Well, how do you turn a 12 to a 3? Divide by 4. Divide by 4, so it would be 25% or 2,500. The probability of selecting red is 25% or 2,500, which, how would you describe that? Would it be impossible, unlikely, likely, equal chance, or certain? I would say it's unlikely I would get red. All right, so this is called the weird horse race. What you're going to be doing is you're going to be selecting, we're going to be like kind of betting here. Ooh. And there are 12 numbers to select from. You are going to be rolling 2 number cubes. And then we're going to find the sum of those 2 number cubes. And we're going to mark it. And we're going to see which horse you think will land, reach the finish line first. For example, let me get my thing. Roll 3. Roll 5. 3 plus 5, the sum is 8. Ugh. 8. Let's roll again. Oh, this is going to be a pain in the butt, I realize. Roll 1. Roll 6. 1 plus 6 is 7. Roll 5. Roll 4. The sum is 9. This is taking a little longer than I thought it would be. So I'll just dump some numbers on here. Dot, 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 dot. Yay, dot, 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 dot. Ooh, 7's in the lead. Dot, 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 dot. Ooh, we're getting 3. Dot. Oh, 7's about to win. Dot. And 7 won. Oh, how is that possible? So 7 won. 8 could have won. 6 could have won, as you can tell. 5 could have won. So the thing is, or study is, why does certain horse numbers win compared to other horse numbers? This is where now it's taking thinking now. Every year I do have somebody who choose 1 or 12. I feel so bad for those kids who choose 1 or 12. Can you explain why 1 or 12 will not win if you roll 2 number cubes? Just think. If I roll 2 number cubes, the lowest I get is 1. Or sorry. 12 is okay. I'm sorry, 12 is okay. But 1, let's look at 1. Why is it why is it impossible to get 1? I don't know why. I cannot write on here. Because if the lowest on a number cube I can roll is a 1, and the other number cube is a 1. 1 plus 1, the sum is 2. I can never get a 1 by rolling 2 number cubes. What about 12? The only time I can get ever 12 is I roll a 6 and roll another 6. That is really, really hard to do. Rolling a sum of 2 or rolling a sum of 12 is extremely difficult. I know in gambling, there's a game called Craps. I've never played it. I've watched it. You've probably seen it on TV or movies where people roll something called a snake eye. A snake eye is rolling a 1 and a 1. If someone rolls that, they're betting with them, and then you can win some money if they can do that. It's a really difficult to roll it. And today we're going to find out the odds of rolling a 1 and a 1. So List all the possible outcomes if you roll the first number cube. If I roll a number cube, here it is right here. I can get a 1, a 2, a 3, a 4, a 5, or 6. What about the second? A 1, a 2, a 3, a 4, a 5, and a 6. So you're going to create a table for rolling. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I roll a 1, then another 1. I roll a 2, then a 1. A 3, then a 1. A 4, then a 1. A 5, then a 1. And 6, then a 1. Then I roll a 1, and a 2. A 2, a 2, a 3, a 2, a 4, a 2, a 5, a 2, a 6, and 2. So the first dice, I roll a 1 again. But then the second one, I roll a 3. So it'll be 2, 3, 3, 3, 4, 3, 5, 3, 6, 3. I roll a 1 again. The second dice is a 4. 2, 4, 3, 4, 4, 4, 5, 4, 6, 4. First dice, I roll a 1. And then the second dice, I roll a 5. So 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5. And then the first dice, I roll a 1 again. And the second dice, I roll a 6. 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. So this is the table listing all of them. Again, let me highlight this part right here. To roll a snake eye, which is a 101, or to roll 2 6s, is really to roll a sum of 1, to roll a sum of 2 or sum of 12 is really, really hard, as you can tell. So this is a sum of 2. This is a sum of 12. So to tell each is certain, likely, unlikely, impossible, immature. The sum of rolling of the dice greater than 12. Greater than 12. Can I even get greater than 12 if I roll 2 dice? That is going to be impossible. Rolling 2 2s or rolling 4 4s. 2 4s. Let's look at our table. 2 2s right here and 4 4s. That is unlikely compared to all of that. The sum of the dice being between 2 and 10. 2 and 10. That's 1 plus 1 is 2, and it's all here. So it's all of this. So that is highly likely of that happening. Rolling a 1 to 6 on the first die and 1 to 6 on the second die. That is certain that's going to happen. And the sum of the 2 dice being less than 4. Less than 4. 1 plus 1 is 2, 3, less than 4. So it's only these 3. So it's unlikely of that happening. So now you are going to actually find out the numbers now without using descriptive words. What are the chances of getting a 1-on-1? It's 1 out of 36 chances. If you look at this table, 1 with 36 chances here, 1 out of 36. What are both even numbers? Both numbers have to be even. So this is one where I will be using a highlighter. Both even numbers. Highlighter. Both even numbers. Well, let's see. Well, it can't be this one. The 1 column cannot be 3 and 5. So 2, 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6. Both of these are even numbers. So they're 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 36 chances of that happening. Which simplified to 1/4 or 25% of that happening. Rolling a 2 and a 3. How many 2s and 3? Let me use a different highlighter. 2 and 3. 2 and a 3. Here's a 2 and a 3. Here's a 2 and a 3. Any other 2 and 3? That's only a 2 out of 36 chance of that happening. Which simplified to 1/18 chance. Both numbers have to be odd. Both numbers are odd. So let's go back to this table. Both numbers are odd. Odd. Let's see. Both odd. 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 So is 9 out of 36 chance, like the other one. That makes sense if you think about it. So 9 out of 36 or 1/4. And a number that adds up to 7. How many numbers add up to 7 here? Let's see. Let's circle. 7, 7, 7, 7, 7, 7. It's a diagonal. It says 6 out of. There's 6 ways to land that adds up to 7 or 1, 6. That's the reason why landing 7, you always hear when you roll dice, is lucky number 7. There are a higher chance of landing a 7 than any rolling a sum of 7 than any other way. So what you're going to be doing after you figure this out is you're going to be practicing more with these, with more things. So you're going to be roll both dice together 20 times, record a number in the table. So now roll both number dice together 20 times, record the outcomes in the table. So you're going to write down all the different numbers, like 5 and 3, and then you write down the sum and so on. And then you're going to be answering question of it. And then, or we just looked at the table for the different ways of doing it. So today is just number cubes. In a number cube, there are 6 ways of rolling a dice. If you roll another, if you have a second number cube, there's 6 ways of rolling it. Together, there are 36 ways of rolling it. And we're going to be learning that very soon when we learn compound probability, where 36 comes from.